Yes, good afternoon, students. I hope I'm audible. So last class we started with the midpoint ellipse drawing algorithm. Okay, and we have discussed a few basics with respect to that. I started recording. So here we have mentioned that it is similar to circle, but the difference is it is an elongated circle. So either you can have one x-axis as a major axis and a y as a minor axis, or the other way around. Maybe a y is a major axis and x is your minor axis. And we have seen that the equation of the circle can be written as x square by r square plus y square by b square is equal to 1, where a square and b square represents your radius. In case of a circle, your a and b will be equal, and hence we are going to represent it as r, and you will end up with the equation x square plus y square is equal to r square. Same thing when we are making use of ellipse. Okay, so at that time you can represent your radius with respect to your major axis, that is with respect to your x-axis. We have represented as rx over here, and the b is represented as ry, and we have rewritten the same equation as ry square x square plus rx square y square minus rx square ry square equal to 0. So this will give us the ellipse equation, and based on the equation you are going to decide upon if whatever point you are finding, okay, if that point if you are inserting the coordinates of the point in the equation, whether you are able to find the location of the point. Is the point lies on the ellipse, or is the point is inside your ellipse, or it is outside your ellipse? So that decision can be made given this equation and your x and y coordinate. Okay, so based on this background, we have started discussing about two different regions in your ellipse. Whereas in circle, it goes for 8-way symmetry, wherein calculating the coordinates of one octant is enough to generate the coordinates of remaining 7 octant in your circle. Whereas in case of ellipse, you need to go for 4-way symmetry. So in case of 4-way symmetry, you are going to identify the coordinates of 2 octant, which is nothing but you are going to identify the coordinate of one complete quadrant, so that you can get the coordinates of remaining 3 quadrants. So we have seen this diagram wherein you have your ellipse. So this is your first quadrant. So as you can see, the radius, okay, or the radius, whatever line we have here, it varies with respect to R1 and R2. So at the center point at 45 degree, where your slope is equal to -1, okay, and you have two regions R1 and R2. So above this slope, your slope value will be equal to less than -1, and below this 45 degree your slope is greater than -1. So we have seen here you have R1 and R2, right? So and this is your yk and yk minus 1. So in case of region 1, okay, your x will be incremented at every iteration, and you are going to make a decision about whether to continue with the same value of y, or you have to decrement the value of y. Okay, in case of region 1, your x is incremented at every iteration and you are deciding the value of y. Whereas in case of region 2, your y value, okay, your y value is you are going to decrement. Okay, initially it was yk, now it is yk minus 1, and now you are going to make a decision whether you have to go with the same value of x or increment the value of x. So R1 region, you are going to decide about the value of y. In R2, you are going to decide about the value of your x, whether to increment or same value. Here, whether to decrement y or same value. So that decision is made. So your region 1 and region 2 have some property. In region 1, you are going to start from 0 and ry. So that will be your starting point, and the slope will be less than 1. Okay, and your x is incremented at every iteration. You are going to decide about y. Region 2, the slope of the curve is greater than -1. Your y is decremented at every iteration, okay, till you reach the end of this quadrant. And the starting point, okay, the starting point of your region 2 will be the end of your region 1. So wherever your slope is equal to -1, so that will be your starting point. Fine. And here in region 2, your y is decremented at every iteration, and you want to decide whether to increment your x or go with the same value. So that decision is made. So based on that background, we have done the derivation of region 1. So as mentioned before, in region 1, x is incremented and you are going to make a decision about y. Okay, so hence your x is incremented at each iteration. So your x can have a value xk plus 1, here also xk plus 1, and you want to decide about yk, whether to go with yk or yk minus 1. So as we are going for midpoint ellipse drawing algorithm, we are going to take an average of x and y coordinate. So when you take an average, this will be xk plus 1 plus xk plus 1 divided by 2, which will give me xk plus 1, and yk plus yk minus 1 divided by 2. So that will give us, it's the average of x coordinate, average of y coordinate. You will get xk plus 1, yk minus 1 by 2. Okay, so this is our midpoint. So next, in our equation, in our ellipse equation, this is our ellipse equation, right? We have seen this ellipse equation over here, right? This is our ellipse equation. So we are making use of that equation. So here you are going to substitute your x and y value. Excuse me. Here you are going to substitute your x and y value. What is our x value here? Our x value is xk plus 1. So xk plus 1. And your y value is yk minus 1 by 2. So we'll substitute x by xk plus 1 and y by yk minus 1 by 2 in the ellipse equation. So this is our first decision parameter. So next, the next decision parameter, that is your pk plus 1. So what to do in that case? We have to just replace your k by k plus 1, right? So we just wrote k by k plus 1, and y of k, we rewrote it as y of k plus 1, right? So as we know, in region 1, your xk plus 1, you are going to increment, okay? There is no need to decide, right? Because at every iteration, we are incrementing our x. So we can directly write xk plus 1 as xk plus 1. Okay, so now this look like a plus b whole square, right? So it looks similar to that. And then this is yk plus 1. You have to keep it as it is because you are not sure whether you are going with the yk or yk minus 1. So we are going to keep it yk plus 1 itself here, minus 1 by 2 whole square and the remaining thing. Right, so we are making use of this equation, that is a plus b whole square is equal to a square plus b square plus 2ab. So make use of this equation over here. So in this case, your a is equal to xk plus 1, b is equal to 1, right? So substitute that. This will be xk plus 1 whole square plus 1 square plus 2 into xk plus 1. Okay, similarly, this will be yk plus 1 whole square plus 1 by 4 and then minus 2 yk plus 1, right? So once you substitute that and do the simplification, you end up with this, that is ry square into 2 into xk plus 1 plus rx square, and this is your equation. Okay, this is the equation which okay, this is our pk plus 1. So here what we are doing, we are taking the difference of your decision parameter, that is p1 of k plus 1 minus p1 of k. So we have done the subtraction. So once that is done, then we are going to check when your pk is less than 0. Okay, when your decision parameter is less than 0, which means you are going ahead with the previous value of y. Okay, whatever midpoint you have, right, we have calculated. So midpoint is near to yk. Your midpoint is near to yk, hence you selected yk over here. Okay, and substitute in your previous equation. You can substitute, you need to do the substitution. So here we have pk plus 1 is equal to pk plus, you are going to replace wherever you have yk plus 1 with yk, right? So you will end up with this. So p1 of k plus 1 will be this equation. Similarly, the pk when it is greater than or equal to 0, your yk plus 1 will be yk minus 1. So substitute your yk plus 1 with yk minus 1 in the equation. Okay, and the simplified equation you will get this. So once we are done with this, like when it is near to yk or when it is near to yk minus 1, you have calculated the equation for both. Then you need to calculate the equation for initial parameter, right? So when you actually start calculating your coordinates. So initial parameter, what we are considering is 0 and ry, right? Ry is already will be given to you. So here you can just put wherever x is there, you have to replace x with 0 and replace your ry with whatever value is given. So in the equation, in this equation of p1 of k, you are going to substitute the value of x and y by 0 and ry. So the final value or the equation which you get is equal to ry square plus rx square divided by 4 minus ry into rx square. Fine. So this is the equation for initial parameter. So till here we have discussed in the previous class. If you have any doubt with respect to derivation, you can ask, okay, because I'm just going to continue with the same derivation now, because we are just done with the region 1. Now we have to see at what point I need to stop deriving for region 1 and start for region 2. So that we need to see. Is it clear till here? Is the derivation for region 1 is clear?
Yes, ma'am.
Good. Before we start with the region 2, first we need to see what is a stopping condition for region 1. So we have seen that we have two region R1, R2, and there is a slope in between which will be equal to -1. So the stopping condition is this slope, right? When your slope is equal to -1, at that time you are going to stop calculating the coordinates of region 1, and then you are going to start with the coordinates of region 2. So the stopping condition of region 1 is this, when slope is equal to -1. So let's see how to find that slope is equal to -1. Again, we are going to consider our ellipse equation, which is ry square x square rx square y square minus rx square ry square is equal to 0. Okay. So this is radius at major your y-axis. This is the radius as x-axis. Okay. Ry is radius at y-axis. Rx is the radius at x-axis. So now we are making use of derivatives. So what do you mean by derivatives? So derivatives is a function that gives slope at some x value. You want to calculate the slope here, right? For a given value of x, you want to calculate a slope. Hence, we are going to make use of derivatives. So before we actually solve this derivation, let's see the derivative rules. So these are few derivative rules which we need while solving this derivation. So what we have for a given, for any power of x, like x raised to n, when you are doing d by dn, okay, derivative with respect to x, then it will be equal to n into x to the power n minus 1. So for example, if it is x raised to 3, then it will be 3 into x raised to 3 minus 1. Okay, sorry, I think this should be x. Okay, so 3 into x raised to 3 minus 1. Next, if whatever x you are trying to do, that is a function, okay, if it is within some function, at that time, and here c is a constant, d by dx of constant multiplied by function of x. At that time, how we can do the derivative? You can take the c, which is a constant outside, and d by dx of function. So later you have to see what the f of x stands for. Say for example, f of x stands for x square plus x. So at that time you are going to replace this with x square plus x, and for x square again you are going to apply this rule. Okay, so like that you can enter inside the function and do the substitution. Next, derivative of any constant. If c is a constant and you are trying to take a derivative of that constant, then that derivative will be equal to 0. For any constant, if you are trying to take a derivative, the result is 0. Okay. So based on these rules, we are going to find the derivatives using this, or you can say slope for a given ellipse equation. So let's apply dy by dx to your ellipse equation. This is the same ellipse equation I have written over here. Then we are going to separate your x and y values. Okay, so yeah, here we have dy by dx, right, and rx square y square. So we are trying to separate this x square and y square. You want to separate it. So dy by dx into y squared. So this rx square, I'll take it this side. So we got it. And what we have here, ry square x square. So what basically we are doing is, we are going to take ry square x square to the right hand side, rx square ry square to the right hand side, whereas you are going to keep dy by dx rx into y square in a LHS, and whatever rx square, it is a constant, right? You are going to place it to the right hand side like this. So what we got, rx square ry square minus ry square x square divided by rx square. So next, apply a derivative. It's y raised to 2. Y raised to 2. It is similar to this, right? So what you can do, n into x raised to n minus 1. Similarly, it will be 2 into y raised to 2 minus 1. 2 minus 1 is 1. So we have not written anything over here. By default, it's 1, right? So here, we are going to just split this. So dy by dx. So rx square, ry square divided by rx square. So that we wrote, and minus dy by dx ry square x square divided by rx square. So as you can see in this equation, so rx, ry, rx. So what are these? These are the radius at x-axis, y-axis, x-axis. So which means it is a constant, right? So it's a constant, hence we are going to ignore this. We already know, like when you have derivative of a constant, the result is 0. So let's ignore this. So what do we get? Dy by dx is equal to, okay, so this thing, so when you are going to apply x square, it will be 2 into x raised to 1. So so equation becomes minus 2 into ry square into x divided by 2 into rx square into y. And we know that when your slope is equal to 1, which is in between region 1 and region 2. Okay, what is the condition for slope should be equal to minus 1? In order to have a slope to be equal to minus 1, we know that slope is equal to dy by dx. Our slope is equal to dy by dx, and you want to find a condition when slope is equal to minus 1. When your slope is equal to minus 1, when you have your 2ry square x is equal to 2rx square y. When these two are equal, right, then you will end up with minus 1. When 2ry square x, 2rx square y, if both are same, then you will end up with minus 1. So that is a condition, right? You want to find that condition. So the condition is when dx is equal to dy, okay, you can say that your slope is equal to minus 1, which means that is the end of our region 1. Is it clear? So this slope we are trying to calculate so that you can identify the stopping condition of region 1. Stopping condition is slope is equal to minus 1. So in order to calculate slope, we are making use of derivative. Okay, in the derivative, the final equation what you got is this. In order to make this equal to minus 1, what is the condition? Your numerator should be equal to denominator. And our numerator is what? It's a derivative of x. And denominator is what? It's the derivative of y. Okay, when these two are equal, you can say your slope is equal to minus 1. So this will serve as a stopping condition for your region 1. Okay, any doubt here? Any doubt? You can just take it on, and if you have any doubt, you can ask. Yes, are you done? Can I go to next slide? Just let me know. Can I go to next slide?
Yes, ma'am.
Yeah. I hope you don't have any queries here. So next is this, we are going to do the derivation with respect to region 2. So when we go to region 2, the decision is with respect to x, right? Because your y will be decremented at every iteration, and you are going to decide whether you want to continue with the previous value of x or you want to increment the value of x, right? So we have seen over here, correct? So in region 2, your y value is decremented at every iteration, and you will decide whether to continue with xk or xk plus 1. So based on that, again, same way like how we did for our region 1, take a average of your x coordinate, average of your y coordinate. So you will end up with the coordinates xk plus 1 by 2, yk minus 1. So this is our midpoint. So now you want to make a decision whether our midpoint is near to xk or it is near to xk plus 1. So based on where your midpoint lies, you are going to make a decision about whether to choose xk or xk plus 1. Okay, so now this is our ellipse equation, right? Same equation which we used in a previous slide. So in the equation, substitute the value of x and y with the midpoint value. What's the midpoint value? You're going to replace your x with xk plus 1 by 2. You are going to replace y with yk minus 1. Okay, so we did it here. So let's represent it as P2K. So this is our decision parameter. Because it's a region 2, we have kept it as P2. And in the previous slide, it was a region 1, hence we kept it as P1. Okay, just for convenience. So here we have P2K. So next, for the next iterate, for the next decision parameter, that is P2 of K plus 1, you are going to replace K with K plus 1. Okay, so we have replaced y of k with y of k plus 1. Then other things remain same. And in the next equation, you can see, because we know that in every iteration your yk is decremented, you can rewrite the equation by substituting yk plus 1 by yk minus 1. Okay, so then we get our second equation for P2 of k plus 1. So next, you have going to perform a subtraction of P2k plus 1 minus P2k. Okay. So next, what we have? So we have, so let's take this. So ry square. So first we'll consider ry square xk plus 1 by 2 whole square minus, because we are doing minus over here, minus, let's consider ry value from your pk. Okay, so that will be ry square xk plus 1 by 2 whole square. So next we are taking rx value, rx square. So this is for pk plus 1. So you can represent this as a minus b, where a is equal to yk minus 1 and your b is 1. Right, minus, consider your kth value, which is rx square into yk minus 1 whole square, right? So that we have over here. Next is this constant, that is rx square, ry square, and because we are doing subtraction, this is also minus, so minus minus will become plus. Rx square, Ry square. So these two constant we can cancel because they are same. So next, you can apply your a plus b whole square equation. That is a plus b whole square is equal to a square plus b square plus 2ab. So that equation we have used here. So this is substitution of that. Next, again a plus b whole square, use the equation, you will get this, plus this is a minus b whole square, right? So we'll do a square plus b square minus 2ab minus Rx square. This is again a minus b whole square. So minus Rx square I'll keep, a square plus b square minus 2ab. Okay. So next, let's combine your Ry terms, Ry square. So let's just take Ry common and combine these two. So once you combine, you'll get this. Then you can 1 by 4 minus 1 by 4, we can cut those two. And this is Rx square, Rx square. So let's take Rx square common. So whatever terms you have is within this. Okay, so this will be again a minus b whole square. So a square plus b square minus 2ab, that is for this, plus 1, okay, minus, this is minus 2 into yk, minus minus is plus 2, right? So plus 2. Then you have this Rx square we have taken outside, so minus will enter, so minus into yk square, right? Minus 1 and plus 2yk. Okay, once this is done, then you can cancel out your yk because they are common. This is plus and this is minus. We can cancel that, and this is plus 1 and minus 1, plus 2yk and minus 2yk. So we have cancelled it over there. And here you can see you have minus 2 into yk plus 2. So you take minus 2 common, you will get yk, okay, we'll take 2 common, you will get yk minus 1. So why we have done it? Because you want to replace, we have taken minus 2 common, you got yk minus 1. So what we get? Minus 2 into y of k plus 1, because k minus 1, right? Yk minus 1 is nothing but y of k plus 1. So hence we have written it as y of k plus 1. So this, after substitution you got this. So the final answer is of difference of p2 of k plus 1 minus p2 of k is this equation. Okay, ry square and x of k plus 1 square, x of k plus 1 minus xk square minus xk plus rx square multiplied by 1 minus 2 into y of k plus 1. How we got y of k plus 1? I have written over here. Okay, so you can just take it down, and if you have any doubt with respect to any step over here, you can ask. And let me know once you are done. Go through the step and see you understand it. It's not difficult. You just the flow remains same. Okay, whether it's region 1, region 2. The main thing is you have to remember only this equation, and this equation how we got, I already explained in the first slide, right? So you can make use of that equation, and then the only thing is just replace it with the midpoint. Then you are going to subtract your pk plus 1 with pk, okay, and make use of equations like a plus b whole square or a minus b whole square for simplification purpose, and you will get your result. So derivation is simple. Yes, are you done? Can I go to next slide? Because derivation still we need to do, right? We just calculated P2 of k plus 1 minus P2 of k. Now you have to see when it is less than 0 what happens, greater than 0, and then the initial decision parameter. Yes, can I go to next slide?
Yes, ma'am.
Yeah. Okay. So as I mentioned before, here you're going to make a decision about your xk, right? So this is our midpoint, and in this case, in a region 2, yk is decremented at every iteration. So initially it is yk, then it is yk minus 1, it will go downwards. Whereas xk, okay, you are going to decide whether to go further or stay in the same place. So first you are going to calculate your midpoint and then see if the midpoint is within a boundary, then you are going to select your xk. And if the midpoint is outside the boundary, which means it is near to xk plus 1, you will be selecting xk plus 1. So decision is based on whether the midpoint is inside the boundary or outside the boundary. If it is inside boundary, you are selecting xk. If it is outside boundary, you are selecting xk plus 1, right? Okay, so previous slide we have seen that P2 of k plus 1 minus P2 of k, we got an equation. So same equation I have written over here. We have just taken your P2 of k to the right hand side. Okay, it's the same equation otherwise. So next what we are going to do, we are going to check the condition, that is if decision parameter P2 of k, that is region 2 of k, is greater than 0. Okay, if the region 2 of k is greater than 0, then which means your midpoint is lying inside the boundary. Hence, you are going to select x of k plus 1 is equal to xk. So now in your equation, in this equation, you are going to substitute wherever you have x of k plus 1 by xk. Okay, and then you will end up with this. So P2 of k plus 1 is equal to P2 of k minus 2 into y of k plus 1 into rx square plus rx square. So you will get this. Next is when your midpoint is outside the boundary. So this is the condition, that is P2 of k is less than or equal to 0. You are going to select your x of k plus 1, okay, because your midpoint is outside the boundary. Next, in the same equation, you are going to substitute your x of k plus 1 with x of k plus 1. Fine. You can just substitute, you will get this equation. Simplify it, you will get this. That is P2 of k plus 1 is equal to P2 of k plus ry whole square into 2 of x of k plus 1 minus 2 into y of k plus 1 rx square plus rx square. Okay, so this is the final equation which you get when your decision parameter value is less than or equal to 0. So once this is done, the next step is to calculate the initial decision parameter. So at the region 2, what is the starting point of our region 2? Okay, so you're going to obtain the starting point of region 2 at the end of region 1, right? So at the end of region 1, you are going to select a condition, that is when dx is equal to dy, your slope is equal to minus 1. Hence, you are going to select that value of x and y. Okay, you are going to select the value of x and y such that the dx is equal to dy, if that is if it satisfies that condition. So that x and y value you are going to substitute in the equation of your P2 of k, right? So here instead of writing xk or yk, what we are going to write? You are going to substitute the value of x and y which you got when dx is equal to dy. So we are going to substitute for now because we are not actually solving any numerical, it is just a derivation, hence I am just considered x and y. So this will be ry square. You can just multiply it with x plus 1 by 2, and here plus rx square into y minus 1 square, 1 whole square minus rx square into ry square. So it is this point, okay, the slope, and this is our r1, this is our r2. At this, the point is, the value for this point is x comma y, and it satisfies the condition that slope is equal to minus 1. Okay, yes, you can take down this, and if you have doubt you can ask. See, for understanding purpose I have drawn few diagrams here at the right side. It's better you take it on so that you know what actually you are trying to do in this derivation. Yes, everybody please mute yourself. Yeah, do one thing, I'll just mute everyone. Yeah. Okay, just go through this. If you have doubt, you can ask. Yes, let me know once you are done. Yeah, are you done?
Yes, ma'am.
Okay. Yeah. So this is whatever we have discussed with respect to region 1 and region 2. This is entire algorithm for your midpoint ellipse drawing algorithm. Okay, this is the entire algorithm for region 1 and region 2 together. So there is slight variation. Let's see what it is. So what we have is, initially you will be given with two radius, that is at x-axis and at y-axis. Then what we are doing, we are going to initialize the starting point of region 1. Okay, because you already know what's the value of ry. You know how to start, right? So starting point is x is 0 and y is ry. So next, based on the value of your x and y, you are going to calculate P naught. That is the initial decision parameter of your region 1. We already calculated derived the equation for initial decision parameter for your region 1. That is ry square minus rx square, ry square plus 1 by 4 rx square. So this is the initial decision parameter for your region 1. So next you are going to take dx and dy. I hope you remember dx and dy, right? Slope of the curve we just calculated. In order to say it is equal to minus 1, you need to have dx is equal to dy, And we have seen that dx is equal to 2 ry square x and dy is equal to 2rx square y. Okay, so hence we have taken dx and dy because you want to know the stopping condition of your region 1. What is the stopping condition? When dx is equal to dy, then you are going to region 2. So that's why you need to calculate this at every point. So let's go to region 1. So in region 1, first thing what you are going to check. So repeat while dx is less than dy. So at region 1, the value of your dx will be less than your dy. When it becomes equal or greater than, which means now you are going to enter your region 2. Equal is the starting point of region 2, and then slowly it is going to dx is going to be incremented. Okay, so let's just continue with region 1 first. So first condition is with respect to dx and dy. Your dx should be less than dy. Then you are going to plot x and y. What's the x and y value? It is the initial value, that is x is 0 and y is equal to ry. We are going to plot that value. Then as usual, we are going to check the condition. If p1 is less than 0, okay, you are going to check your decision parameter value. If it is less than 0, then you are going to select your next value of x, that is x is equal to x plus 1. Okay, and x is incremented at every iteration, so we will be just going with x equal to x plus 1, and there is no change in y in this condition. You are going ahead with the previous value of y because your midpoint is near to yk. So x is equal to x plus 1, so you are going to update your dx because x value is incremented, hence you are going to update dx. How we are going to update dx? In order to update dx, you have to calculate a new value of 2 into ry square into x. So what is the x value here? The updated x value is this one. We have done x equal to x plus 1. So initially it was 0. Now it will become 0 plus 1, which means 1, right? So the new value will be 2 into ry square into 1. So that will be the updated value of dx. Okay, new value of x you need to take. Or what you can do is whatever old value of dx, like whatever the previous value of dx is, for that you can do the addition. You can perform addition by 2 into ry square. At the end you will get the same result. Either you just substitute the new value of x, do the multiplication, you will get the answer, or for an old value of your dx, you are going to add 2 into ry square. Again, because ry is constant, okay, you can just add the constant at every iteration. So either you can go with this or you can go with multiplication. Go with multiplication or addition. That is your choice. I have written both over here. So next, you are going to calculate your P1 value when your decision parameter value when it is less than 0. We already have the equation derived in our previous slides. So that is P1 is equal to P1 plus 2 into ry square into x plus ry square. So this is the it is the decision parameter value when your decision parameter is less than 0. Next, else condition, when it is greater than or equal to 0, when your decision parameter is greater than or equal to 0, x value we are incrementing and y value we are decrementing, which means your midpoint is near to y minus 1. Okay, and in this case, because both x and y value have changed, you need to calculate dx and dy. You need to update the value of dx and dy by making use of new value of x and y. X value which is incremented, so that value you are considering, and for y value which is decremented, so that you will be considering and calculating. Here I have done multiplication. I made use of this multiplication thing. But if you are not comfortable with multiplication, you want to go for addition, you can go ahead with that. Instead of writing this, you can write old value of dx plus 2 y square, and in this case old value of dy plus 2 rx square. Okay, so you can either do addition there or you can just do the multiplication. Next, then you are going to update your decision parameter value. That is P1 is equal to P1 plus, I have written dx and dy, this is from our equation. In our equation we have got here as 2ry square x minus, for dy we got 2rx square y. Okay, I'm just substituting it. I'm just for simplification, I just wrote dx minus dy because we already know what is dx value and what is dy value. Okay, so this is done, and this is for your region 1. So next, for region 2, what is the condition? Here the condition is dx is less than dy. For region 2, the condition is dx is greater than or equal to dy. So once you get this, you are going to consider the initial decision parameter. So P2 naught, initial decision parameter, will be equal to, so in this you have to substitute x and y value. Whatever the last x and y value I got from my region 1, x and y value, updated value of x and y value, last updated value of x and y value from region 1. So that is considered over here. You're going to take that x and y value into your initial decision parameter equation and calculate the decision parameter value. Okay. And once it's done, then repeat till your y is greater than 0. Okay. Till your y is greater than 0, you are going to continue. Why? Because in region 2, your y is decremented, right? Your y is decremented at every iteration, and you are going to continue till you reach. Okay, you are going to continue till you reach this point. So at this point, it's a horizontal line. At this point, your y will be equal to 0, right? So hence, repeat till y is greater than 0. Till y is greater than 0, you are going to repeat it. Okay, till your y is greater than 0, you will repeat. And once it becomes equal to 0, okay, you are going to stop. So plot x and y. So whatever the last value, so that you have going to plot. Then we are going to check your decision parameter condition. If your decision parameter is greater than 0 that you have calculated over here, if it is greater than 0, then you are going to continue with the same value of y, and y is x, and decrement the value of y. Okay, which means it is near to x. Okay, your midpoint is near to xk. And your y you are going to decrement in every iteration because we are in region 2. Then because only y value have changed, hence you are going to update your dy. Again, your dy is nothing but 2rx square into y. Then you are going to update your P2 value. So this derivation is already done. That is P2 is equal to P2 minus dy plus rx square, where dy is this value. And then else condition, when your decision parameter is less than or equal to 0, this is the condition. You have x is equal to x plus 1, y equal to y minus 1. Okay, and your dy is equal to dy minus 2rx square. Okay, why we have done dy is equal to dy minus 2rx square? Because your y is decremented whereas x is incremented. So obviously you need to increment the value of x. So hence we have done 2 into ry square while you are incrementing value of your dx value, right? Whereas when you are dealing with dy, because the y value is decremented at every iteration, you need to do decrement. So dy minus 2 into rx square. Either you can go with this, okay, or the same thing you can rewrite. You can rewrite like this. Either you can just calculate dy in this way, or a new value of y, a new value of x you can substitute in this, you will get the same answer. Okay, if you are not comfortable with this, just multiply, you will get the same result. Then the new equation for decision parameter will be P2 is equal to P2 plus dx minus dy plus rx square. Okay, so and so you will reach the end when your y is equal to 0. Fine. Just go through the algorithm once again and see if you understand it and take it down. After this, we'll solve a numerical based on this. So you go through each line carefully, okay? Because we are going to solve numericals in the next slide. So if you mess up here, then you will end up with the wrong result later. Don't just take it on, make sure you understand it. Because when we are did the derivation for region 1 and region 2, we have not considered dx dy, right? So I have explained why we need dx dy in one more slide saying the slope of the curve, right? So there I have explained what do you mean by dx, what do you mean by dy, and what is the condition when you need to stop calculating the coordinate for region 1, right? When your slope is equal to -1. And when your slope will be equal to -1, for what value of dx and dy your slope is -1, right? So that we need to see, and we have seen the condition that when your dx is equal to dy, at that time the slope is equal to -1. So using that condition, we are going to write this algorithm. So we have considered in region 1 when your slope dx is less than dy, okay, that is when your slope is less than -1, and similarly in region 2 when dx is greater than or equal to dy, okay. So accordingly we have written this algorithm. So we have to update your dx and dy value whenever you change the value of your x and y. If you change it, then you need to update it, else no. Let me know once you are done writing. This thing over here is or. Okay, either you can go with this or you can go with this. Yeah, can I go to next slide? You need time? Okay, are you done writing?
Yes, ma'am.
Okay, thank you. So this is a problem based on midpoint ellipse algorithm. I've just taken one problem. I think once this problem is done, we'll wind up our class. So what we have initial thing what we will be knowing is Rx and Ry, right? So we'll read the value of Rx and Ry. In this case, it is 8 and 6. So initial value for your region 1, the coordinate value for region 1 is 0 and Ry. So Ry is already given, which is 6. So 0 comma 6. So we are going to plot that value. Okay, you can just make this table. So what we have xk, yk, the initial value, decision parameter, because you have to decide whether you are going with P1 or P2. So if you are dealing with region 1, it will be P1, and if you are dealing with region 2, it will be P2, right? And then xk plus 1, yk plus 1, that is the next decision parameter value. Okay, and this the dx and dy, because you have to make the decisions. Okay, I think I have to do some changes in this. Okay, so this is where your region 2 starts. I have written for region 1. This is region 2. Okay, yeah. So first what we'll do, we'll have 0 and 6. So initial value is given. What's the next step? So once you have 0 and 6, you are going to plot 0 and 6. Next, you are going to check your P1, right? So for that, you need to calculate P0. So P0, substitute in the equation. So what is the equation for P0? This is the equation ry square minus rx square, ry square plus 1 by 4 into rx square, right? This is our equation. So on that equation, substitute the value of Rx and Ry, and your X and Y value you already know, X is 0 and Y is 6. So once you substitute, you will end up with this result. Okay, the resultant value is minus 332, which is negative. So when it is negative, you are in region 1, it is negative, which means it is less than 0. You are incrementing X and updating your dx and updating your P1. Okay, so we'll increment X, which is 1 comma 6, and you need to update your dx value less than, right? Yeah, we're going to update our dx value, that is 2 into 1 into 36, and here we are updating dy as well, right? 2 into 6 into 64. Why did I do dy? Hmm. Okay. Okay, here we are. Okay, for dy, yeah. So, so what happens here is we are taking the whatever new value of x we have taken 1. Whereas for y there is no change, but you have not calculated your y value before, right? So we are going to take a previous value of y itself. What's the previous value of y? It is 6. So we are going ahead with 6. So 2 into 6 into your what is this? This is rx. Rx is 8, so hence it is 64. 2 into 6 into 64, we got 768. Okay, that is the previous value of y. Okay, so we calculated it. So for next step, the next value is 1 and 6. Again, make use of your p value. Okay, so p value you have to calculate. Sorry, so p value is this one, right? So this you need to do because you have updated dx, you have to then update p value, that is p1 is equal to p1 plus 2 into ry square x plus ry square. Okay, we are making use of this. Okay, substitute it, you will again get some value. In this case it is minus 2 to 4. Because it is minus, you are incrementing your x value, y you are keeping it constant. So updated x value, x is what, 2, right? So 2 into 2 is 4. So 4 into 36, 144. Y we are going ahead with the same value. Again update your P1. So it is the second iteration where we are updating your P1. So new value of x and y is 2 and 6. You updated your P1 value, which is minus 44 in this case. Again it is minus, you are incrementing your x, and the new value of your dx is 6 into 36, because it is 2 into 3, right? 2 into 3 is 6. So 6 into 36 is equal to 216, and same value of y. Again, in third iteration, you are going to make use of P1 is nothing but minus P plus whatever our equation is, right? We have our equation here, right? So this you are going to substitute, right? You will get 208. 208. Okay, it's a positive value. So when it is positive value will come here, which means you are updating your x and y both. So x is x plus 1 and y value is y minus 1. Where is it's here? So we increment updated x value, right? And you are updating your y value as well. So y value will be it will be reduced, right? So whatever the initial value, you are going to reduce it. 2 into 5, 5 to, so it's 10. 10 into 64, it is 640. So we have reduced our y value. Again, so this will be 4 comma 5. So second iteration, so P1 is equal to, so this is the equation, so that is this equation, P1 plus dx minus dy plus ry square, right? So we are making use of this. So this is a new term get added over here, that is so that is dy minus dy. So you can see over here in this equation, we have a new term, that is minus dy. What is minus dy? It is 640. So minus 640 is given over here. So result value is 108, because we are incrementing x, because it is negative, wherein you are only incrementing x. So if x is incremented, y no change. So this value will be 10 into 36, that is 360, and y remains same. Okay, so you can just check the condition. Every iteration, make sure you check the value of dx and dy. So in this case, your dx was less than dy, dx less than dy, dx less than dy, here also dx less than dy. And whereas when you reach here, okay, in this case it is still dx is less than dy. But when you reach here, that is 504 and 384, your dx is greater than dy. So at this point, your region 2 starts. Okay, because the condition is satisfied. Now your dx is greater than dy, which means you have entered your region 2. Okay, so you have entered region 2. So again the region 2 rule will apply. Okay, so this is for this 2, 3, 4, 5, 6. This is okay. I have to write it below. Region 2. Okay, fine. So once this is done, so now the region 2 rule will apply. So at 6 is 4. This is at region 2. So you have to make use of region 2 rule. Okay, so here you can see it is P2 of 0. We have changed it to P2. Till here we have used P1, P1, P1 because it's in region 1. And this is P2, P2 because you are taking consideration that it is in region 2. So P2 of 0, initial parameter, this one. So initial decision parameter is ry square into x plus 1 by 2 square plus rx square into y minus 1 whole square minus rx square into ry square. So this equation we are using over here. Okay, and replace the value of rx and ry with the given value, x and y with the initial value. Okay. So you will get, what's x and y? Well, x and y will is this 6 and 4. Okay, so that you have to see wherever you can substitute. We'll go ahead with that. Then you will get the answer as minus 23. Okay, x value is 7, x plus 1 by 2. And what's the y value? Y minus 1. So y minus 1, we directly wrote it as 2. Instead of writing 3 minus 1, we have written 2. This is x plus 1 by 2, so 7 plus 1 by 2. So x value is substituted, y value is substituted after subtracting with 1. Okay, and this is our ry value, and this is our rx value. Okay, so once this is done, then it's a negative value. When it is negative value, which means your X value is incremented and Y value is decremented. Where is it? It's here, else condition, right? Your X and Y value is here. Your X and Y value is X is incremented and Y is decremented in a else condition. So here you can see your X is incremented and Y is decremented. Then you are going to calculate your d of X by making use of this equation. You will get 576, and similarly you will calculate dy, which is 256. Again continue, because you have to continue till your y value reaches 0. So 8, 2, again substitute in the equation your P2 of 1 calculated. You will end up with 361. It is a positive value. So when it is positive value, no change in your x value, whereas y value is decremented. Because we are in region 2, your y value is decremented at every iteration. So that we have to keep in mind. So x is constant and here y is decremented. And because y value has changed, no change in x, so same value. And for y, a new value of y you have to consider, which is 1. So you will end up with 2 into 64, that is 128. So next, again, because it is 8 and 1, decrement 8 and 1, we have to still continue because your y has not yet reached 0. So we'll continue with this. So P2 of 2 we have done. This is second iteration. Calculate the value of your decision parameter. In this case, it is 297. Again, because it is positive, x value, no change, y value we are decrementing, so that is 0. We need not calculate the value of dx and dy because your y value has already reached 0, and that is a stopping condition for our coordinate, right? Because y value already reached 0, which means I am already here. So I need not do. We started from here, we reached this position, right? This was 0, comma ry, and this is rx comma 0. We reached this position, so let's just stop there, right? Your x value is 8, it is 8. Your y value is 0, 0. So that will be 8 comma 0. We started from 0, 6. This will be 0 comma 6. So now we have calculated the coordinates of our first quadrant. Okay, all coordinates we have calculated for our first quadrant. Similarly, you can calculate the coordinate for Q2, right? What will be Q2? Same value you write, okay, but the y value is negative. The second coordinate, this will be 0, 6, 1 minus 6, 2 minus 6, 3 minus 6, 4 minus 5. Like that you have to write. And when you want to calculate for quadrant 3, both x and y value will be negative. So 0, 6, then minus 1 minus 6, minus 2 minus 6, minus 3 minus 6, and so on. And at fourth quadrant, your x value is negative and y is positive. So 0, 6 is there. All x value will be negative and y value is positive. So it will be minus 1, 6, minus 2, 6, minus 3, 6, and so on. Okay, so this is how we can solve the numericals for midpoint ellipse algorithm. So if you want more example, you can just change the value of rx and ry. So now I have given 8 and 6. You can try 2, 4, 3, 4, 4, 3, something like that. You can try and you can get the solution. Okay, any doubt? You can just take it down.
So, ma'am, do we
Yeah.
use the same method when it's like the other way? For example, instead of 8, 6, we have 6, 8.
Yeah, you can try that. It should work.
Okay, same algorithm.
Yeah, you can just take it on. So once you're done, let me know. So we are done with the ellipse midpoint algorithm. So as you know, next week is your assignment, and the computer graphics assignment is scheduled for next Saturday. So it's a quiz which consists of 20 questions. It's MCQ or fill in the blanks type of question. And each question carries half mark. So entire quiz is for 10 marks. And the duration for the quiz is 30 minutes. I'm sure a circular is already given to you, right? You know the timetable, no? Did you receive timetable?
Yes, ma'am.
Ma'am,
Yep.
we didn't get the timetable. It's supposedly different for departments and branches and stuff.
No,
So
from
as
department wise, okay. But computer graphics is on Saturday, okay?
okay, ma'am.
It's on Saturday because it is October 2. You will not be having class, only quiz on that day, okay? So I'll schedule your quiz at 4. So it will be from 4 to 4:30. So make sure, please don't miss your quiz. Yeah, if it's done, are you done writing?
Yes, ma'am.
Yeah. Okay. Because we have done derivation for region 1, region 2, and we did a numerical on this. So I'm going to stop here. So next class onwards, I'll continue with the next concept. Okay, I'll stop recording and end this meeting.